we're going to talk about compounded interest now. Last time we talked about interest that was just paid annually. So you deposited money into an account and they paid you a certain percentage once per year. So now we're going to see interest that's compounded a certain number of times per year, whether that's monthly or daily or weekly or bi-monthly or semi-annually. There's lots of different terms. What's important to know here is that the number of times that it's compounded is in the equation here, and that's going to be the end value. So this p-value, that's the principal, that's the starting amount, that's the initial amount. And now instead of just 1 plus r, so last equation, it was just 1 plus or minus r, depending on if the money was growing or depreciating. So now we're talking about money growing, and we're going to do 1 plus r divided by n. And that rate is still a decimal, but now the new part is n, and that's the number of times the interest or whatever is being paid out is compounded, and that's going to be per year. And then the exponent is n, so again, that n value, the number of times it's compounded, and then for how long, how many years are you investing this money for? So some things to understand is that the number of times compounded annually, you might want to know that there's 365 days per year. This is just information that maybe you don't know. There's 12 months per year. Okay, there's 52 weeks in a year. So that's just information that we're going to assume that you know. So if we say that the interest is compounded weekly, you have to know that there's 52 weeks in the year and that your n is 52. So as we look at this first example, you're depositing $5,500 in an account that pays 3.6% annual interest. Find the balance after 3 years if the interest is compounded monthly. So now we're expecting you to know that monthly means n equals 12. That means that you have to know that there's 12 months in the year. So it's compounded, that's the number of times it's compounded monthly. The number of times is 12. Then we want you to realize that this 3.6%, that's your rate. Remember, we're going to change that into a decimal, so we're going to make that 3.6 into 0.036. Remember, you take that number and you divide by 100. That will give you the decimal equivalent of your percentage. And then find the balance after 3 years. So that 3 years, we're trying to tell you that t equals 3. And of course, over here, this $5,500, that is the p-value. That's the starting value. So if I want to go ahead and find out what my answer is, I'm going to take that 5,500 and I'm going to go ahead and plug that into my formula. 1 plus my rate of 0.036 divided by 12. And then my exponent is 12 times 3, n times t. Ideally, we want you to keep this in your calculator 100%. If you can't keep it in your calculator 100%, that's okay. The first thing you're going to do is you're going to type this in your calculator. And then you're going to add 1 to that. Then you're going to take that and you're going to raise it to the 36th power, because you should hopefully know that 12 times 3 is 36. And finally, you're going to multiply that with 5,500. So when you do all of that, you should end up getting a final answer of $6,126.27. Since we're talking about money, it naturally makes sense that we're going to go ahead and round to 2 decimal places. So before we do this last example, I kind of need to show you where this Euler's number comes from. So if we look at the equation that we just had, where we had compounded interest, we're going to be moving into something called continuously compounded interest. Continuously compounded just means that it's compounded every minute of every second of every day. I know it's kind of like weird to think about, but when I show you where the formula comes from, hopefully you'll see that it doesn't really matter if you're compounding it 100 times or 100,000 times. It's not really changing your answer that much. So Euler's number comes from this formula right here, 1 plus r divided by n over n, or to the n power, sorry. And you can hopefully see the similarity between that compounded interest formula and then that Euler's number formula. So what happens if you type this in your calculator, where you allow n to be, we'll start with 10, and then we'll say n equals 100. Then we can even say n equals 10,000. We can say n equals 100,000. So what we're doing is we're going to take n into this formula, and we're going to say that r equals 1. So we're going to go ahead and say 1 plus 1 divided by 10 to the 10th power. And if you type that in your calculator, you get 2.59374, etc. Then we can say, okay, 1 plus 1 divided by 100 to the 100th power. And you type that in your calculator, and you're going to get 2.70481, etc. We say, okay, let's now try to the 10,000. So now we're going to have 10,000. And we type that into our calculator, and you're going to get 2.71814. Keep going. And we say, okay, now let's try typing it into the 100,000. So 1 plus 1 over 100,000 now. And we get 2.71827. Keep going. And we wanted to try one more, and we wanted to do the 1,000,000th. So we're typing that into our calculator, and now we're getting 2.71828. So you can kind of see the progression here. So basically this 10, 100, 10,000, 100,000, 1,000,000, that's the number of times that your interest or whatever is being compounded. And you can kind of see that the value here is not changing that much. Sure, from 10 to 1,000,000, it changes about a tenth, a little bit more. But the difference between 10,000 and 1,000,000 is minuscule. And what I really want you to notice is that this right there, that's Euler's number. That's the E. That's the 2.71828, etc. So as we move into this next example, we have something called continuously compounded interest, which now has its own formula. And we can kind of see the difference between a compounded interest. Compounded interest had that formula where we had all that big stuff inside the parentheses, and now we've kind of replaced all of that with E, and we've popped that R onto the outside. So as you think about needing to memorize these formulas and understanding which formula goes with which kind, the key word here is continuously. Continuously compounded, you're going to use the E formula, and we just shorten that kind of as PERT. So let's go ahead and fill in these. You can see that the variables really mean the same thing, that A, the ending amount, that's what's on the outside of the equal sign. P is the starting amount, the initial amount, the principal amount. They all mean the same thing. Your rate is always going to be expressed as a decimal, and then time is usually in years. So we're going to use this formula. We've got $3,000 that we're depositing into an account, so that's going to be our starting amount, our initial amount. The account pays 3.5%, so that's going to go ahead and be our rate. So we'll change that 3.5% into a decimal to be 0.035. Remember, you divide by 100. And then compounded continuously is telling us that we're using the E formula. Now, what's the balance after 7 years and 4 months? So this right here, this is the trick to the problem. This is really the new thing. So we know how to plug things into formulas. That's not hard. But 7 years and 4 months, now we have to convert that into years because time is in years. So we can't have this mixed years and months business. So what you should do is you should change this to 7 years and 4 months. So 4/12. 7 and 4/12 of a year. You should never make that into a decimal, because if you have 4/12, that's going to be 0.3 repeating, and you can't really actually truly represent 0.3 repeating in your calculator as a decimal. So we're going to go ahead and say that our time is 7 1/3 years. So as we put this into our calculator, into our formula, we're going to say A equals that initial amount, and then we have E, and then we have our rate, 0.035, and then my time is actually going to be 22/3. So where did that 22/3 come from? It's just converting that mixed number into an improper fraction. 7 times 3 is 21, plus 1 is the 22/3. That's all that is. So now you should be able to type that straight into your calculator. And if you can't type that into your calculator, go ahead and do this part first and then multiply by 3,000 at the very end. And it's talking about money, so we're going to go ahead and round to 2 decimal places. So we'll have $3,877.84. That's it.